Welcome. In this lesson we're going to look at angles which are measured in degrees. And let's first start with a little terminology. In order to create an angle, we always have a starting point, which I'll mark here in blue, which is called the vertex. This line, or ray rather, that we're starting with is called the initial side of the angle. Let's say we're starting at the initial side and we're sweeping out a certain amount as indicated by this line I'm drawing. Let's say I stop right at that point. Well, our terminal side then would be the straight line which would extend through that end of our sweeping motion. Again, that is called the terminal side of the angle. Now technically, angles could be drawn anywhere in two-dimensional space, but what we're frequently going to do is adopt something called standard position. Now what standard position does is, instead of letting the initial side be just anywhere, we always start with our vertex at the origin, and our initial side will correspond with the positive x-axis. We have our x and our y-axis. Notice, as should be familiar to you from graphing, that we have 4 quadrants making up this plane. Alright, then from our initial side we can sweep out an angle as wide or as narrow as we wish. Let's just suppose for this example that I go all the way to the y-axis. Then the y-axis in this case would be our terminal side. Now of course that 90-degree angle there is also known as a right angle, and since it takes 90 degrees to go through quadrant 1, since we have 4 quadrants, this should remind you the commonly known fact that a circle has 360 degrees. It takes 360 degrees to revolve around a circle. Now there are certain angles that are going to come up so frequently in the study of trigonometry that I thought I'd start with those. I have a bunch of angles drawn here, but notice I've simply denoted that 0 degrees would be, of course, no rotation at all. Right angle, 90 degrees. If we go around to the left, we have 180 degrees, and then 270 degrees down at the bottom. These are sometimes called quadrantal angles because they fall on the edges of the quadrants. Let's look next at the red lines, which I've drawn here. The red lines would correspond to 30 degrees, 150 degrees, 210, and 330 degrees. But I'd like you to notice that in each case, these red angles marked in red are exactly 30 degrees from the x-axis. Now let's look at the angles determined by the green lines. We would have 45 degrees, which should make sense to you. It's exactly between 0 and 90. And then 135, which is exactly in between 90 and 180. Similarly, 225 and 315. And finally, those blue lines there would correspond to 60 degrees, 120 degrees, 240, and 300. If you follow me through these lessons, those angles will come up so frequently that you'll know them in no time at all. Next, we're going to talk about the idea of a coterminal angle. You know, in fractions, for instance, every fraction can be written many ways. For instance, 1/2 equals 5/10. Well, similarly, there's more than one way to name an angle. Let's look at the angle 390 degrees. Now, using standard notation, we of course would start on the x-axis, and we know that it's 360 degrees just to make it around the circle. So notice at 360 degrees, we're right back where we started from. Well, since we made that full revolution, let's subtract the 360 here. That would leave us with 30 degrees. So at this point, I just need to make another 30-degree trek into quadrant 1, which would be roughly speaking, about right there. Well, notice when we traverse the first 360 degrees, it's kind of like we were spinning our tires on this, in the sand, you know. And then at that point, we got back where we started. We only had 30 left. So, yes, you could call this a 390 degree angle, but it would certainly be much simpler to just refer to it as a 30 degree angle. 390 and 30 in degrees are coterminal angles. But I'll just suggest right now, I would certainly prefer to express that just as the 30 degrees. Let's look at a negative angle and approach it in a similar way. For a negative angle, we would start out on the x-axis because we're going to be using standard notation. Now, when you have a negative angle, the difference is instead of going up, you go down. That is, you go clockwise. So if we go down clockwise, that would take us to a terminal angle corresponding with the negative portion of the y-axis. So we call that a negative 90 degrees. Now, I was suggesting just a moment ago that since there are so many ways of writing an angle, we might want to write it in the simplest possible fashion. And generally, here's what we're going to do. When using degree measure, we'll normally express our angles in the form. Now, theta is just what I'm going to call the arbitrary angle. We'll let theta be in between 0 and 360 degrees. Notice I have the equal sign pointing to the 0 but not the 360. That's because 0 degrees and 360 degrees are exactly the same thing. We might as well go with just calling it 0 degrees. Now let me show you how we'll do this in practice. So for my next example, I'm going to start with an angle of negative 350 degrees. Alright, so we have our initial side on the x-axis. It's a negative angle, so we go down instead of up. That is, we go clockwise. So let's start going around. Now, I'm going to do that rather quickly because obviously 350 is almost a complete revolution, but it's not quite a complete revolution. Although my drawing here is only an approximation, that would probably be roughly what our angle would be. Actually, probably a little bit smaller, but it would be hard for you to even see it in that case. Now notice, we simply lacked the final 10 degrees to get down to the x-axis, our starting point. So expressed as a positive angle, this little portion here is 10 degrees. So in other words, negative 350 degrees and 10 degrees get you the same place. We call those coterminal angles, but as I said a moment ago, we'll prefer this. That falls between 0 and 360. Let's do one more example while we're at this. Sometimes you'll actually see an angle expressed as something that would represent more than one revolution. Here would be such an example. I have 765 degrees. Now that's a positive angle, so at this point you know what I'm going to do. I'm going to start on the positive x-axis. It's positive, so I'm going to go up. That is counterclockwise. Now, 765 is a rather big number, so of course I'm going to make a full revolution of 360. And let's just subtract that away to see what we have left to work with. That will be 405 degrees. Well, heck, I can make a whole nother 360 degree revolution there. So let me just draw it here. Make a whole nother circle. We've taken care of another 360 degrees. That would leave us with 45 degrees. So at that point, we've been spinning our wheels in the sand here. Our final result's just going to come from that last little 45 degrees there. Now we know that that should give us an angle right in between 0 and a right angle, so it would look, roughly speaking, like that. And our resultant coterminal angle is 45. 365 and 45 are coterminal, but this would be a much easier form to work with. In my next lesson, we're going to look at similar ideas involving radians. I will be defining a radian and showing you how to do that in standard notation. All right, signing out.